This is video 39 on MicroPython and LVGL 9.3 on a Raspberry Pi Pico. LVGL has two layout features, Flex and Grid. In this video, we start to use LVGL Flex. Please let us know in the comments if you like this example, or let us know if you have suggestions to improve it. For this effort, the software is developed on a Pico2W using our standard baseboard and utilizes the ILI9341 display. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. Our goal for this effort is to introduce the LVGL 9.3 Flex widget in a simple program. We shall discuss the new Pico2W firmware. We will jump into the research by walking through an outline of the various LVGL Flex statements as discussed in the LVGL documentation. Then, to improve our understanding, we demonstrate two programs. First is one of the LVGL example demos, normally in C, but we've migrated it to MicroPython. We will also briefly look at its code. Then we will use a second demo and review its code. The program files are at the GitHub site that is mentioned in the description and endnotes for this video. For this program, we built the June firmware for the RPI Pico2W. As you know, the Pico2W is somewhat new still. This firmware displays a proper banner signifying the version is 1.25. It contains the LVGL and ULab modules. And because it has the Wi-Fi and Bluetooth hardware built in, the standard network modules are also included. We continue to use the standard driver files. To begin, let's look at our findings from the LVGL documentation. As this is just an introduction of the Flex, I'm going to try and keep the explanation simple. Flex involves a parent container and its children objects. The parent sets the Flex flow, known as a track, for children. The doc then explains that Flex Align manages the placement of the children in the track, and Flex Grow manages the size of each child object. This slide lists the Flex flow directions in the track. For example, row displays each child object in a row, and row reverse simply reverses the order. Flex Grow defines the size of each child object within a track. Each child object is set with a grow value. In the example, there are 3 child objects with grow values. Based on this setup, one object fills 50% of the container, and the other 2 fill 25% each. Now that we have an idea of the approach, let's see what actually happens. We shall open the 2 demonstration programs in Thony. I've already clicked the green run icon to execute the first program, which is test_flex_display.py. In the first row, we have a container with 6 buttons. Underneath the row, we have another container with 6 buttons, but in a column. Notice that the first container scrolls right or left, whereas the second container scrolls down or up. In fact, let's try that. I can change the behavior of these buttons by using the set Flex Grow features of my program and restarting the program. Let's do that. So in the program, I have an option to change the Flex Grow. We'll change it to true, and we'll stop the program. Restart it. Notice now Flex is forcing the objects to fit inside the container. And further, I change the weight of one item to be twice the size of the other items. So you'll notice that in the row container, number 1 is twice the size of the other, and the same in the column. It's twice the height of the other items. All right, let's look at the code. So this is a standard LVGL program, and it uses the standard driver. Nothing new there. We can scroll down to where the action is happening. And here we've defined a container object. So notice that the container is just an object. We set its size and we set its alignment. So on line 41, we've set the container as a row flex flow object. On the next object, you can see it's different slightly by its size and the fact that it's set as a column flex flow object. Then I have this option to set whether we grow it or not. So when it's false, it's not going to grow, and the container is allowed to scroll to the right and left if it's a row object, or up and down if it's a column object. And this is pretty much the program as found in the LVGL documentation online. All right, let's stop the program and we'll put in the next program. Okay, we've got the second program, which is test_flex2_display.py. I've already clicked the green run icon. This program is somewhat similar, but I made the second container dynamic. With the grow option off, each button is the same size, and the controller scrolls if there is not enough space. Let's give it a try. These buttons are active. Okay, the first button is going to display 6 countries. And notice that only 5 of them are in the display screen at the moment. So we have to scroll to see the 6th country. I can click a different object, and here I've got the states. So there's 4 states being shown. Let's click on the local object. Okay, those are 4 cities. All right, let's see what happens when we use the Flex Grow feature. We do that by setting the option to true. Now we're going to restart the program. All right, let's click on the world object. As you recall, it displays 6 countries. All right, we've clicked on the world object. Notice this time, all 6 countries are fit into the screen. Let's click on the national button. All right, there was only 4 states, as you recall. Now, all 4 states are fit into the screen, and the buttons for each object are the dimensions are increased to fit that entire area. Let's try the local. All right, if you recall, it was going to display just 3 cities. Notice now the buttons have gotten even bigger to fit the entire screen. Let's look at the code. All right, this program is defined similar to the other. It's just using the standard LVGL features that we have in most of our programs. Let's scroll down to the containers. So this time, instead of having a row and column, I just have 2 column containers. I've defined some labels for the count and the amount, and we can click on one of the items, and I just put a random number out there. Here's all the arrays for the button containers, and here's the draw child. So notice what I'm doing is I'm using the clean feature, which removes each of the children objects from the container. So we start out when we press a button with a clean screen, and then it's populated with each of the children objects based on the list, the array list. Then you'll see in lines 99 through 105, I have that option to either grow or not. And what I did is one of the options will grow twice the size of the others. And I do that with this conditional code right here. And that's about it. The rest of the program is pretty simple and straightforward. You'll be able to look at that. What I was trying to do was demonstrate the impact that using Flex can have on your screens and the features that it can give you. In summary, in this video, we discussed the new Pico2W firmware. We introduced the LVGL Flex layout. We demonstrated 2 Flex examples with row and column containers, and then with the option to grow the children objects or not. We reviewed the program code. Hopefully, you have a better understanding of the LVGL 9.3 Flex layout. And, although the code was written and shown on the Pico2W, the features should work for any of the Pico and ESP32 platforms. Please comment if you feel other changes are needed. I hope this video helps you with your LVGL MicroPython coding. Really thank you for listening.